My name is Noam Ziv, and I'm a computational linguist, emphasis on linguist. Linguist first, computational second, or maybe ninth. Okay. All right. Our system, ASR system platform, is so advanced, so we're the only engine that can really understand what the Swedish chef is saying. I think most of you are too young even to know about the Swedish chef. The current situation as we see it subjectively, I don't have any scientific academic research done. It's research done by our customers, benchmarks done by our customers. I'm talking about voice command, not transcription, not dictation, not IVR. Okay, and the benchmarks, they show clearly, and it's from 2016, and I think that Dragon already incorporated DL in their large vocabulary engine. This shows that we're far from being home safe, and the systems are not yet commercial. And that's from my experience. I cannot prove it, but from my understanding of the industry, I think this reflects the situation correctly. Anyone here has a Google Glass? That proves my point. And we reach in one simulator 74%, 78%, 87% with Sphinx, which is a completely different story, okay? I'm comparing apples and oranges. And Noam recognized that after investing a lot of work in specifying the grammar, we managed to reach 84% and couldn't go beyond it. Okay. So what's the problem? And why I'm using the term glass ceiling? A baby says, Mama wa Seuss mi iPad. And the mother understands immediately, I want to watch Dr. Seuss on my iPad. How can she do that? Okay? Almost 80% of the words the toddler is saying are incomprehensible. So the answer is always contextual considerations, linguistic intuitions, all kind of buzzwords, which we don't know exactly what stands behind it. But today we need it, because without it, without semantics, pragmatics, syntax, and lexicography, and phonology, and all those buzzwords from linguistics, I think we won't be able to get to a commercial level of voice command interfaces to existing applications. So in this lecture, I have only 20 minutes. I'll demonstrate to you 3 semantic, linguistic, syntactic mechanisms which we already use and help us surpass and break the glass ceiling. 1, transformations. Second, word class expansion. Instead of, you see a number in the corpus, okay, and you expand the corpus to serve any number at that place. I'll show you to in a minute. I know some of you are already using it, but they're not using it in a semantic way. And synonyms, okay? How can we use synonyms without causing any chaos? But, okay, once, say, we manage to expand, enlarge, and improve, enhance our language model or the corpus we're using for machine learning, how can it help us in real life? Talking about Google Voice, for example, you cannot expand or enhance the language model because you cannot access it. So what we do, and we'll show it to you, is a post-processing enhancement mechanism. After Google finished the work and Dragon finished its work, they all offer us about 5 different interpretations. We take all the interpretations, sometimes it reaches about 30 competitive alternative sentences, and from this we create the real interpretation that reflects correctly the user intention. I'll show it to you later. Syntax-based engines. I need water. Okay. Especially in R, probably most of them, you know it, we can enhance the grammar. The better the grammar, embedded grammar, the better it is, the better the interpretation is. And now talking about specific application, domain-based application, where you specify the grammar and have come up with a customized engine, you can reach almost 90% success, and this is very close to the glass ceiling. And of course, Kaldi, Sphinx, all of you are using it, speaker independent toolkit. Okay, in that case, you directly generate the language model. So you can generate a language model based on text only. So the more text you have to learn, the better the language model becomes. In case you have some input text, so machine learning can create a language model out of it. In case of voice commands, that's a real problem because we don't have any examples, we don't have corpus, we don't have transcribed audio because it hasn't been used until now, okay? Now, how can transformations help us enhance the language model? Say you have 1 million sentences in the corpus. All of them are statements. If you manage to transform all of them to questions and do it correctly, so you have a 2 million sentence corpus, and you improve it by a factor of 2. So it looks very simple. You take the first is, okay, take it all the way to the left, add a question mark, and here you go. Well, that's not the case. The man who is tall is happy. I hope most of you have heard this sentence. This is a very famous sentence by Chomsky. That's his latest video clip, which was viewed by millions of people. And he shows the problem here. The sentence seems to be awkward, but all the sentences Chomsky is using are awkward. And that's his challenge on statistical computational linguistics. So I'm going to use his example because that's what I'm doing here exactly. The man who is tall is happy. Here we go. That's a simple transformation rule. A is the man who tall is happy. That's bad. That will corrupt your language model. That will corrupt your corpus, and the machine learning you'll do on it will be corrupted as well. You cannot afford to enter ungrammatical sentences into the examples. So how we solve it? Simply by parsing. Okay, before you want to analyze the sentence before you implement the transformation rule. So the man, well, what I'm saying here is very simple. The man is tall, is happy. Which man? The man who is tall. You see, that's an embedded sentence. Once you are aware of it, the rule is very simple. Take the first structural is, not the first linear is, the first structural is, and here we go. Okay? So all you need is to parse the sentence. And then you can multiply the sentence you have by almost by 10 with simple transformations. And you have a bigger corpus and much more rich example base. All right, but you have to parse it. I thought the minute I say parse it, I'll count to 5. Half the audience would have already left, and the half is considering to leave the lecture. I see most of you are still here. I'll get to it later. It's not impossible. Once it was impossible. We do it all the time. There are some ways to go about parsing the corpus without getting lost. It's quite a robust area now. Another example, word class expansion. Say we have a sentence, to turn 180 degrees back. Oh, did I do that? What did I do wrong? Oh, okay. It killed the surprise. So instead of 180, you can write any number, okay? So this way you enrich your corpus, right? Very simple. But you allow for a sentence to talk about 3,500 degrees, which is nice if you have Celsius or Fahrenheit somewhere in the vicinity, but you don't. So you need to be a bit more sophisticated in order to do semantic, I'm afraid to touch it, okay, semantic word class expansion. I believe all of you are doing word class expansions all the time. But if you parse the sentence before you expand the words, okay, by a shadow parser, not a sophisticated parser, a shadow parser, you know that the 180 belongs to degrees. You look in the dictionary, degrees can move between 1 and 360 if it's not heat. All right? So now you have this as an input to your language model algorithm, and it makes it much better. I know it from real experience. It can add about 2 percentage points to your success rate only by that. Last one is very famous. Do you have time? How much time do you have? 5 minutes? Okay, 6, that's all good. Synonym expansions. You all remember when Google added the synonym algorithm to the queries. So you ask, where can I find gold? So it gives you a response in order to discover gold, etc., etc. That caused a big chaos. Okay? They had to pull it back. It was, this algorithm, this mechanism was much too wild. So if we add a semantic synonym algorithm into our corpus, then this is, of course, Chomsky's example. I got it from his student. I found Trump attractive on Sunday. I found eggs under my pillow. Now, if I just replace found with discover, I get ungrammatical sentences. I discovered Trump attractive on Sunday. Does it make sense? You want to avoid it? All you have to do is a small shallow parsing, and you have to write in the dictionary that the predicate found allows for a centennial sentence, but the predicate discovered does not allow centennial sentence. So the rule is a bit more complex, but not too much, and you generate these 2 sentences, and the language model becomes much more rich. Now, let's get back to numbers. These are the numbers I quoted from a year ago. We're talking about a simulator, emergency room simulator, with many patients simultaneously, and you manage the emergency room. You don't do nothing. All you do is to talk, and there's background noise. And if you ask the nurse to give an injection to this patient, and she gives it to another patient, you fail. Okay, so that's the test. These are the numbers we reached. Our customers in the States say that's not good enough. We can't use it. So we used our algorithm on Google only, added another 12 points, 12%, that's not percent points, reached 86, not good enough. 88, not good enough, okay? But we took all of them together, the 4 of them together, we managed to break the glass ceiling. And that's real data, real findings from the market. And now it can be used. But we had to use 4 ASR engines, each one from a different type, completely different type, grammar-based, training. Dragon and Google are the same large vocabulary. And I'll show you in a minute how we did it. In Hebrew, which is much more demanding, I say Hebrew is all the non-English languages, which ASR-wise are much way behind. Okay? In that case, we managed to improve it dramatically, but that's not no big issue because we're not even close to the glass ceiling with Sphinx, etc. There's no difference between English and Hebrew in Sphinx, okay? It uses what you give it as an input, but still, it's getting better. The more work you invest, the better you become, until there's a point where you cannot improve anymore, and that's about 91%. Altogether, we broke the glass ceiling, and a customer here in Israel, which I can say it's a child, Ministry of Defense, is using it. After testing it and testing it with background noise, etc., it became commercial, though they don't pay, of course, but it's potentially commercial. How we do it? With one NLU platform, we use as many ASR engines as we can afford, because you have to pay for some of them, and each one contributes a guess, and we take all the guesses, and imagine here we have a list of 10 million legal, valid and sound medical commands in emergency room. So a whole list of 100 million with parameters, so it's huge, okay? It's not, it doesn't work like that. We compare it to an existing command, and we found the closest, the command which makes sense that the user wanted, and we synthesize it. And we come up with Record Amazing Grace Tonight, which no one has offered us. Okay, so we come up with a fourth interpretation, and that's how we break the glass ceiling. Okay, questions? In case you don't have any questions, I prepared some, but I'm not sure I can answer them. Yeah. Okay, I'll ask myself, how can you parse non-English text, non-English conversations, mixed languages, English, Tagalog, and Spanish together? We got it from an SMS company, huge one. The parser fails. Conversational English, the parser fails. Because it is, strictly speaking, non-grammatical English. So how can you parse it? Okay? The answer is you can. You can. With some modifications, you don't use a huge one parser developed in a university, I won't mention its name, to parse all the text you have. No, you come up with specific parsing models. You don't need to go all the way for embedded and recursive embedding in this area, etc., etc. Or you build up, you come up with 100 examples and you start multiplying it by algorithm. 100 parsed examples which you create yourself. 200 examples for Waze, for example. We had a pilot for Waze. We started with 200 voice commands for Waze. You know, if the address changes, it's the same command, okay? That's all they have. You don't have more than that. You can report, you can navigate, that's all you can do. So you have 200 examples, and you also record it, transcribe it. That's how we start, and then you start multiplying it, because you don't have any examples from the real field, because nobody has used Waze in a voice-activated interface before. So you generate it in a very restrained and controlled way, and you can reach a huge corpus, which takes you all the way to beyond 90%. Any more questions I can ask? I have more. All right, thank you.
Actually, I have a question.
Thank you.
Can you comment about somewhat like error analysis, or I mean, what types of different errors you see for the different engines, or did you do that?
Oh yeah, that's the second question here. The dream of having one generic large vocabulary SR engine that serves general language, general English, for example. Not all languages at once, but one engine for one language. That's a dream. We started with it about 10 years ago, and it's not working. It's not working. You have to break it down. I spoke with Amazon. I tried to sell the idea to most of the vendors. They say, hey, it's too early to give up the dream of having one engine for all domains. I say it's useless. Even the human being has different engines for different domains. So start breaking it down. It's not that complicated. It's not that demanding, because then you can unify all the domains you have into one engine. That's what we're doing now for the Army. Thanks.